Well, first of all, starting off with question 6. It goes, put this equation in the form y equals mx plus c. Now what's significant about y equals mx plus c is y is on its own and it's positive. That's what you gotta do. So you look at 2x minus 3y minus 15 equals 0. You have two choices. Option A, bring the 3y over the other side and you get 2x minus 15 equals 3y. And then do a spin to get the 3y equals 2x minus 15. Another option that other people might have done was this. They might have brought the 15 and the 2x over the other side and they said minus 3y equals minus 2x plus 15. Multiply both sides by minus and you get 3y equals 2x minus 15. So you can see both ways actually give you the same answer. Now finally, to get the y on its own, if you had to divide by 3 here, the two of them would cancel, wouldn't they? But in order to have to divide by 3 on that side, you have to keep the balance on both sides of the equation by dividing by 3. 3 divided by 3 leaves the y behind, and that's going to get you 2 over 3x minus 15 over 3, which is minus 5. So 2 over 3x minus 5. So y equals mx plus c is the form they wanted it. So in a way it looks exactly the same structure. M is 2 over 3 and c is minus 5. So actually is in the same structure. What we have next is what it wants 0 on the right hand side and it wants everything else over the left hand side. No fractions if you can help it. Okay, so move the 8x and move the 5 over the other side. So we're going to get 8x plus 1y plus 5 equals 0. Do you see the way the x comes first, the y comes second, and the number comes third? That's all you got to do. So that's question 12 done. Pretty difficult question, that one. Now, question 15. We look at y equals 1/3 x plus 3. Now, what I might do to both sides is what? Give them all a denominator of 3. And then what happens to the 3's on the bottom? Okay, then after that, we're going to move them all over one side. What's 3 times 3, by the way, just while I'm there? It's a 9. Move it out to your side. So I'm going to get minus 1x plus 3y minus 9 equals 0. Can anybody else explain another answer that is also acceptable? Yeah, 3y equals x plus 9. Do you want that? I did actually have that. 1x plus 9. 3y equals 1x plus 9. Then I moved it all over one side. The other acceptable answer is to multiply by minus 1 and you get x minus 3y plus 9 equals 0. Both of these answers are acceptable. Is that right? Now, so over here, I'll just box that off. Oh, there you go. We get rid of 12 now. Doesn't exist anymore. Put 15 up there. Now, what are we on now? 17? 17. Now, y equals minus 2 over 3x minus 2. Get rid of the fraction. How do you get rid of that, Liam? Top and bottom. And it's divided by 3, and that means you have to multiply the top by 3. Why doesn't this one get an extra 3? It's already divided by 3 in the first place, so it doesn't need to be affected. And the whole reason is any number you get, you're doing the same thing top and bottom, aren't you? So are you actually affecting the value of that number? Not really, because the 3's can just cancel back out again, and you're back where you started from. If you chose to cancel it that way, you've done nothing to the equation, because they can cancel each other back out again if you wanted to. Now, we're not going to choose that cancellation. We're going to choose a cancellation like this, where everything has a denominator of 3. Then we're going to move everything over to one side. So we would have 3y equals minus 2x minus 6. Move the 2x and the 6 over to your side to get plus 2x plus 3y plus 6 equals 0. Okay guys, so that was questions 6, 12, 15 and 17.